I've wanted to design and build a chassis stand for my larger sets. For the last couple of years I've been thinking about it, and I finally got it done. And what I had to do is I had to consider first, well, what's the largest chassis that I'm ever going to put on it and want to rotate? And that would be a 12-inch TV like this one here. And these are pretty large and they're very heavy. This is about 80-pound set, and it's pretty typical of the pre-1950 TVs that I work on. It's about 21 inches wide and 17 inches deep. And I wanted the stand to be able to actually have it tilt forward so I have good access to the top of the chassis, and yet be able to flip completely 180 degrees upside down. And I wanted to be able to do that and accomplish it with smooth motion. In other words, not having pins in the side where it would lock it in certain positions. I wanted to be able to just design a clutch system so I could just push the chassis to a position I wanted and have it stay, and then when I wanted to move it again, just push it to the new position. So I think I've got that accomplished, and my next thing I had to consider was mounting sets that aren't easy to mount. A set like this has 4 mounting holes in the bottom of it where it was screwed into the cabinet, and they're sufficiently strong to hold even an 80-pound chassis like this upside down. But a set like these Philharmonics, and I do work on a lot of Philharmonics, they don't have 4 mounting holes on the bottom. So the challenge there is to be able to hold a chassis like that. What they do have is the sides bend and lip in on the chassis. So I need to be able to design a clamping system so that I could clamp down on that lip on the bottom and be able to hold it safely and securely in the chassis stand. I also wanted the stand to be able to make it wider, expand it, and make it narrower, so I can accommodate different chassis sizes. Another important feature requirement is the ability of it to accept 19-inch rack mount. So this SX28 here is a 19-inch rack mount set, and I have a lot of other communications receivers that are 19-inch rack mount, like R390, AR88, and SP600. Plus I also have test equipment that's 19-inch rack mount. So I have to have the ability to have the stand accept these rack mount sets so I can service them on the stand. The stand was designed and modeled in Autodesk Inventor. This allowed me to design the individual components and assemble them and make sure that they all fit together and worked as intended. On the stand here is a 12-inch TV that is one of my largest sets I would use on it, and I'm able to confirm that I have plenty of clearance and I get the rotational degree of freedom that I was looking for. I also modeled up an AR88, which is another large set, and made sure that that worked good on the stand, and that was a rack mount set. So I'm not going to spend any more time on the CAD design here. Let's go into about a minute of video making the parts, and then I'll go right into the finished parts and show you how it goes together and how it operates. These are the parts that I machined for the chassis stand. It's mostly 6061 aluminum that I sent out and had type 2 anodized, though I do have some parts that are made of 303 stainless. So I have two uprights here, and those are what go alongside the chassis to hold it and allow it to rotate. On the inside here I have a plain sleeve bronze bearing, and on the outside there's a ball bearing. And the ball bearing is important to the clutch action, and I'll go into that in a little while. I have thumb screws that go into these holes here, and these accept spreader rods that go across and connect the two uprights together to hold them a set distance. I also have nice rubber feet on here that are on threaded studs, and of course my vanity engraving there. So the way this works is that these swing arms here have an axle, and I made a hex head on it so that when it goes in, it locks with this swing arm and it rotates as one unit. And then there's a clutch plate that goes on it. This is UHMW plastic, and the reason I chose this is that it has real good smooth clutching action and it's low stiction. And this just goes right through the sleeve bearing and out through the ball bearing. These are the clutch tensioning knobs here. And I turned a smaller lip on the inside here. And what that does is that loads the inner race of this ball bearing and puts those balls in compression. And the reason I did that is because it allows the arm to turn and the clutch tensioning knob to turn with it. So if that ball bearing wasn't there, what would happen is this would just loosen, the whole assembly would loosen and tighten as it rotated. Because as you can see now, the knob is rotating with the arm here. So it maintains a set tension, whatever you set it at. And I used fine threads on the axle here so I can have better control over the tension that is on this clutch assembly. And it works really good. You could make it so tight you almost can't even move it, or just loosen it up a little bit and get some nice smooth action. I have my sides assembled now, so now I need to connect them together with the spreader bars. I made the basic bar size 20 inches long, and this will accommodate a 16-inch long chassis. And I made extensions. I made 6, 4, and 2-inch extensions, and they just all screw together, and I could expand it to accept up to a 28-inch chassis. And I milled flats where they connect in case I need a wrench on them. They'll take a 5/16 wrench, but so far hand tightening has proven plenty sufficient. So these just go in the hole there. And to assemble the second side, it's easy, instead of sliding it all the way through, it's easier to just put one in first and then screw your extension or extensions on. All right. So I know whatever the width of the chassis is that I want to put on, I need to add 4.5 inches to it. So I'm going to put a 20.5 inch wide chassis on here. So I want with 26-inch wide bar setup. So I got a 20 and a 6, and that'll work out good for my chassis. The chassis mounting rails get bolted right to this side swing arm. I have 4 levels that I can bolt them at, and I can also move them forward, or I can move them to the rear of the stand, you know, if I want to accommodate a deeper set or whatever. It enables me to do that. It gives me the flexibility to adjust these up, down, and front to back. But when I was designing it, I was also thinking that the center of gravity of the set should be pretty close to the pivot point, you know, so the clutches work and work well. But I've since shown that the set, even heavy set, doesn't have to be that close to the center of gravity. It could actually be pretty far off, because the clutches do work so well that it doesn't matter. They hold, and you can pivot the set freely. So these get mounted from the back of the arm here with a socket head cap screw. They're just 1024 threaded alloy screws. And I keep a dedicated Allen wrench with the chassis stand and all its parts, because this wrench fits not only these side rails, but it also fits the clamps that I made for holding, you know, like Philharmonic chassis and other special chassis. The chassis going up here now is 20.5 inches wide. So I'm just gonna set it at about 20 and say 9/16. All I have to do is just slide it in the bars. And then once I'm there, I tighten the thumb screws and they'll just lock it in place. Yep, I'm good. So now before I put a chassis on it, what I want to do is I want to tighten these, make them really good and snug, so that I could slide the chassis on and they don't pivot on me. So that's it, just slide this 80-pound beast in there. These are the original screws that held the chassis into the cabin. I'm going to put them in. I tightened the front too with an open-ended wrench, and then I flipped it over, so now I could put the rear two screws in. So I have my 4 screws in, and this chassis would be ready for servicing. And as I mentioned earlier, I was concerned about the, especially on the large chassis, the set not being at the center of gravity. And as you can see, this one wants to flip over when the clutches are loosened, so it's not at the center of gravity. Just a little snugging on the clutches, and I could adjust the tension so it will hold in any position. And it'll hold strong too. I've already proven to myself that even when it's pretty far off and it's a heavy set, there's no issue. Once I snug the clutches, then the only way to move it is to actually physically push on it. And I've already worked on this set. I've restuffed the electrolytics, and it was nice having access to the top here. And I pulled the tubes and checked them. And when I align it, it'll be nice having access to the top too. And the bottom, this set actually got hit by lightning, the antenna. The input capacitor was blown to bits, and the input transformer was open. I assume it was lightning. So what I wanted to do is I wanted to make sure the basics were all working. So I actually restuffed about half of the paper capacitors. I did all the deflection circuits and the high voltage circuits. And because I had gotten this set, the high voltage cage was a part too, which is always something that, you know, makes you think that, oh, it's a flyback. But anyway, so I spent about 4 hours. I did that, and I got a raster, and everything's working pretty good. I just have to do the rest of the set. And while I was working on it, it was rock solid. You know, I had no issues. It held the chassis firmly whatever position I wanted to be in. You know, if I want to stand up and do work, I could put it in this position. I could tilt it like this, so when I'm sitting at the bench, I'm right here, and you know, I could adjust it for better access to certain components, and it just works. It holds really well, and I couldn't be happier with it. If I want to test the set and let it run for a while and be able to see the picture and adjust it, I could leave it in this position. And when I was in the garage machining the parts for the stand, I looked down at the floor and I saw this Motorola TS18 chassis sitting there. So I thought, well, how am I going to mount that? Problem with this chassis is that it's missing a corner where the CRT sits, and its mounting holes are in the front and rear, not on the sides. So I obviously couldn't mount it to the side rails, and I ended up designing these cross rails here. And the cross rails are 16 inches wide, and they bolt to the sides, and they're fully adjustable. So this gives me the ability to not only mount in a regular chassis like this, but also one with mounting holes that are front and rear. My rack mount adapters just bolt right to the side rail with 1024 screws. 2 or 3 is plenty. The face of these adapters are drilled and tapped 1024 with a standard EIA pattern. Alright, I have an SX28 up on the rack mount adapters, and I have full and easy access to the underside of this. The only thing you wouldn't be able to do with it on the rack is rebuild the gear train, because the front panel has to come off. But otherwise, everything's pretty readily accessible. These are the clamps that I made for holding the Scott Philharmonic. What they do is they bolt into the side rail through the side here. And this space in here is just a little bit smaller than the thickness of that lip on the bottom of the Scott chassis. So when I bolt these in, it puts some clamping force on that lip. I also put cup point set screws in these ends here so that I could use these on thinner chassis too. I have a Scott Philharmonic on the stand now, and I used 4 of the 6 clamps that I made for this chassis. 4 seems to hold very well, doesn't move at all. And they just clamp on that flange, so I could really put them anywhere I have flange available to clamp. And I got a good degree of freedom here. And ready access to the top, which is good because these IF transformers in here, they have capacitors that come through the bottom of the chassis. So you'd have to unsolder one end, the top here, go to the bottom, unsolder the bottom, solder a new one in the bottom, flip it over, solder the top in. So it's nice being able to rotate back and forth, at least for those. And then there's a base choke box here that it's off on this set. I have it on the side, but there's 4 capacitors there that get replaced, so that needs to be removed and taken apart. And then the capacitor, tuning capacitor cover here, this comes off, and there's some paper capacitors and some resistors in there. And it's good to have ready access without having to flip the whole thing over. On a set like this, you really, I guess most guys probably, they just put a cushion down and lay it upside down on a cushion or something, or a towel, but it's risky, damaging the chrome. And the side will support it on the coil covers here, but it's not very stable at all. And this side you don't want to support on the tube shields. So it works really good, stays in position. Zenith 12A58 on the stand now. Some chassis, the mounting holes are in further, so the trick to mounting a chassis like this where the holes are in further is to flip these bars over and you'll get a lot more room. This notch is cut out in here really for my clamping system for the Philharmonics and other specialty chassis that don't have mounting holes. So when you flip these bars over, you'll get more reach. So anyway, this set here, I already replaced the tune-in capacitor bushings because they're all rotted out as they usually are, and I didn't want the dial to break. But I bought this set here from a guy who's an electrical engineer, and he was pretty much a hack. There were mice living in this set, and you could see the capacitors are just chewed up. A bunch of them are chewed up. And you got just electrolytics floating, and look at this menagerie. I need to, one day when I have time, I just got to go through the whole set and clean it up. It's a real mess. But anyway, back to the stand. Stand works good with it. I made a set of 6 of these clamps here for chassis that have a lip on the bottom that faces out, kind of like the Scott All-Wave 23 or the Philharmonic or All-Wave amplifier chassis. They have a folded out lip. So these would just mount anywhere along the top rail in any of these holes, and you just bolt it down and tighten it up, and it would, clamp that lip. I also have a set screw in them, so if you want, you can tighten up with a little extra force. It's a cut point head, so it'll bite pretty good into metal. That's only if you need a little extra force, but I'm not going to go pulling my All-Wave 23 chassis out of the cabinet to test it on here. I'm going to say it'll work. So for those of you who have made it this far in the video, you might be wondering what this little tit is sticking out here. And it's really just a hard stop. You can see I have a threaded hole here, and I would screw a dowel pin in there, and that would limit my rotation. This would hit the pin and it would be a hard stop. I was just, I guess, a little paranoid about how well the clutches would hold, and I wanted to have a little bit of a safety mechanism built in. But I don't need it. I've never put the pin in there, the dowel pin, and it's just not necessary. So that's what this is about. Of course, if I made another one or did it again, I would eliminate it. But hindsight's always 20/20. Anyway, thanks for watching.